Okay, here we have problem 7.1. Later we'll see how 7.1 and 7.2 are very similar except for one difference inside the function. And we have the ultrasonic sensor, which just detects how far away objects are, or if it's anything's within range or not. We have the threshold, the standard speed for the robot, color sensor, the light threshold. Color sensor is still set to reflected light intensity because that's what we used earlier on. The gain still small. I just took all of these values from, I believe it's assignment 4, around assignment 4, and then we're pretty much just adding in the touch sensor. We have all our function inputs, we have our 3 outputs, right wheel, left wheel, and the current state, while using the robot outside of the running anything inside of Simulink. You don't really need that very much. We have a little key. State 0 is stop, state 1 is moving forward along the line, state 2 is reversing away from the object. So we have our function, and we have our outputs, right wheel, left wheel, current state. We have our inputs. Could put the ... but I guess didn't say anything about it running bad. So yeah, we have the ultrasonic sensor, the distance threshold, the set speed, the light level, the light threshold, the gain, and the button. And then we just have the ultrasonic sensor, double the value, and the light level double the value, because inside the blocks that you don't make, that are pre-made, they do that standardly, so we have to do that ourselves here to keep it consistent. So again, we're using a persistent state. Start off with, if the state is empty, then the state is equal to 0. So after the program initially starts, that is the only time we'll use that statement, that if statement. And then we have our switch state. I guess you could call it function. So if the case is equal to 0, the desired speed is 0, rotation 0, that means that the robot is not moving. But if in this state the button is pushed, so these are just, if the state is 0, it does this until something happens, pretty much, and that something is if the button is pressed, and the state is equal to 1. And then that's the end of that. Ends, we go back all the way around, and the persistent state is equal to 1, so if that doesn't affect anything, then we go down to case of 1, the state is which means the state is equal to 1, desired speed is equal to the set speed. We have that from our nominal speed on the outside where we hook that up. The rotation is equal to light level minus the threshold times the gain. So I believe the gain was something that we had to set that up because of it's not standard in a function because we made the function to do what we want to desire. And so that is just the program for having the having the robot follow the line until something happens, and that if is if the sensor is less than the threshold, then the state is equal or changed to 2. Otherwise, if the button is pressed while in state 1, the state then reverts to 0, so the robot would stop moving. Then that becomes no. We go into case 2, which is state 2, and the desired speed is equal to the negative set speed. And basically what that means is just that the robot's going to go straight on backwards from whatever point that it is at. The desired rotation is equal to 0. So you can see down here the desired, so if the rotation is equal to 0, the right and left wheel will be moving in the same direction at the same speed no matter what. If that is not equal to 0, they will be moving at different rates, which we will use later on for reversing in 7.2. Otherwise, if it is in state 2 and the button is pressed, if it reaches a distance greater than twice the distance threshold, then the state is reverted back to 1 and it will resume its line following status or searching for that line. Otherwise, if it is reversing and the button is pressed, it will go to state 0 and it will stop moving. If something weird happens and somehow none of these are working or come into play, the state is equal to 0 and the whole system pretty much resets. And as we go down, it goes down the state to keep that persistent variable consistent. The current state is equal to the state. Okay, what we have here is the exact same thing from 7.1, which I explained earlier. The only difference we have is that we're trying to make the robot turn around while going backwards. So that requires one very, very simple change. See, we have the same function, output, input, everything is the same except for in case 2, we have a different desired rotation, which I don't know, you could have it as third. It depends how fast you want the robot to turn. I found you need, if the rotation is too small, you really just end up going back on the same line again and again and again, and the robot never actually turns around fully. 50 goes very, very fast. That's what I started with. And I just kind of started from 10, working my way up, and I found that 30 worked pretty well in a lot of scenarios where the robot wouldn't get lost. But what you see here is with the desired rotation is that the right wheel and the left wheel are going to vary. So we have the desired speed plus the rotation, so that means that if with the negative speed, it would be the right wheel is moving slower and the left wheel is actually moving faster, just in the opposite way. So that robot is going to rotate while going backwards. And that will hopefully put it on a more clear path. All right, and hopefully it's able to find the line again if possible. But it won't go, it's not following the line while it is rotating. It is just rotating until it doesn't sense something within 2 times the distance threshold.